Anyway, all right, the session is going to be a little bit interesting because we have already covered the basics of collision. Uh, I hope you remember the collision stuff. All right, let's try this question together. A 10,000 kilogram railroad car A traveling at a speed of 24 meter per second strikes an identical car B at rest. So, okay, let's read out the question first completely. If the cars lock together as a result of the collision, what is their common speed just afterwards? This is a really easy question based on the conservation of momentum because
Hmm.
okay, I will tell you my approach on solving the momentum, the collision question. So I always separate the initial situation and final situation using a dot, and I represent both the bodies over here and both the bodies over here. So this is before the collision, and this is after the collision. Okay, and of
All right.
course this has a mass of 10,000 kilograms, which is moving at 24 meter per second, and yeah, this one is at rest, right? And this is an identical body, so this is also 10,000 kilogram. Now afterwards, it actually will not look like this because remember that they lock together. So whenever they lock together, can I consider this as a single body with 20,000 kilograms traveling with some velocity
Yeah.
v? Do you agree? Okay, all we have to do is conserve the momentum. So the initial momentum is only because of the 10,000 kilogram. So it will be 10,000 multiplied with 24, which is equal to 24 followed by 1234 kilogram meter per second. And the final momentum is going to be 20,000 multiplied with v, where v is the speed. All right, okay, this makes sense. So momentum is conserved, so this means that the final momentum, as in 20,000 v, is equal to initial momentum, which is 24 followed by 4 zeros. So 1, 2, 3, 4, 1, 2, 3, 4, this is gone. And dividing both sides with 2, I have v as 12 meter per second. That is the velocity of the couple just after moving. Does that make sense? Just after colliding, I
Yeah.
mean.
Hmm. Hmm. Yeah.
All
I
right,
see it.
okay. Um, some situational examples which I'm giving you. This is not from the side of book, just to enhance your concept. For example, there's a 2 kilogram object moving at 2 meter per second here, and there's a 4 kilogram object moving at 3 meter per second. uh, I'm sorry, this one is 3 and this one is 2.
Yeah, I was gonna say it would be going away.
Yeah, they cannot collide ever otherwise. They collide, and we have to find that what is the unknown speed of this 2 kilogram object if this 1 kilogram, if this 4 kilogram object is traveling away at 1 meter per second. All right, can you help me with this question?
So we don't know the 2 kilogram speed, but the 4 kilogram is at 1 meter second. Okay, so P initial, would that be MV of the 2 kilo plus MV of the 4 kilo?
Sorry?
Would the PI be MV of the 2 kilo plus MV of the 4 kilo?
Absolutely. So what is pi?
So it's 6 plus 8.
Okay. And what is p
So that
final?
makes Virginia. And P final would be 2V plus 4.
Okay, all right. What next?
So 2V plus 4 is equal to 14. 2v is equal to 10. V is equal to 5. But 5 meters per second.
Right.
Would it?
So, yeah.
So it goes and it hits the 2 kilo and it goes fast. Would it not go -5 then?
Yeah, that doesn't make practical sense because I took the numbers hypothetically. So it may not make practical sense, but yeah, this was just to understand how to, apply the concepts over here. That was the only reason.
Okay.
Okay, all right. 2 kilogram traveling at 2 meter per second. 4 kilogram traveling at 3 meter per second. Please remember that the question will never give you in the way I am giving you, right? So this is just this is just so I don't want to type everything, otherwise it will take a lot of time. But the question will always give you in the word as a word problem, and you have to depict, convert your word problem into
Yeah.
so-called, yeah. All right. What is
Into a
the
diagram.
unknown? Correct. What is the unknown velocity of 2 kilogram?
So the pi would be let me just write pi here actually. This would be 4 minus 12, right? Because the one is coming the other direction.
Absolutely.
And then pf would be 2v once again, plus 16. So that's 2v plus 16 is equal to -8. 2v is equal to -24, and v is equal to -12 per second. So it goes backwards 12 meters per second.
All right, at least this makes practical sense that it has to go backward, of course.
Mm-hmm.
All, both of them changes the direction, so it will be minus 12 meter per second. All right, very good. Next question, let's try a couple of word problems now from the book. All right. All right, let's try question number 4 and question number 7. Is that legible?
It could be a little bit bigger, I'd say, just for the 4 at the moment.
Okay, 1 second.
Like 110 kilograms at 2.5 meters per second. Head on to 82 kilogram halfback, moving at. Does that mean head on, like they collide into each other?
Right, head on means like this.
Face to face. Okay. So that at 5 meters per second. 2 kilogram. Boom, boom, boom. And they form a massive body of 192 kilograms with what V? Pi is 110 times 2.5 and plus 5 times 82. 685. PF is 192 V. So 192 V is equal to 685. 2, 3.57.
Really?
That's what I got. Oh, you have, yeah, 110. Oh, I didn't make it negative. That's right. So, oh wait, then it's like 110 times 2.5 minus 5 times 82. Is that this divided by 192? Negative 0.7.
All right, please be careful about these signs. Next question.
Yeah. Negative 135. 35 equals 0.7 per second. 7. Child in a boat does a 5.3 kilogram package out horizontally with speed of 10 meters per second. The velocity of the boat immediately after, assuming it was initially at rest. That affects the boat if you throw the package 10 kilograms that way, it'll push you backwards.
Correct. So it is assumed that there is no friction or nothing, no external force. So the net momentum is conserved. It is zero. So if you push something away from it, then the net momentum is conserved. So obviously that will impact your velocity as well. So you have to just conserve the total linear momentum in this case.
Okay, well, they don't actually collide.
Yeah, it's like a bullet in a gun case.
Okay, let's see. There's this. The unknown. 24. I feel like the first like PI initial, it's the 5.3 plus 24 plus 35 as a one main body, and then P final is the 10 moving that way and then you moving the other way. Or no.
Childbirth rose of 5.3. Sorry, can you say that again?
I was saying that the P initial would be the 5.3 plus 24 plus 35, but there's no speed.
P initial is 0 because the system is at rest.
Yeah. And then PF is 59V, well, minus 59V plus 10 plus times 55. No.
Okay, so
I
there
don't
are
know how you do this.
two objects. One is the boy and one is the boat. The boy is the mass of the child and the mass of the board. So there are three, I mean, in totality, there are three objects. One is this package, and one is the boy, and one is the boat. But obviously, the boy and boat are going to move with the same velocity. So initially, the package and the boy plus boat, and boy plus boat is 34 plus 35 plus 24, which is
59.
59 kilogram. That's one object for us. And this is
5.3.
5.3 kilogram. That's another object for us. And initially everything is at rest. Now 5.3 kilogram is thrown forward at 10 meter per second, and we need to find that what is the speed of this 59 kilogram boy, which is v. I know that it will be in the left direction, but let the physics give me the correct answer. Physics will tell me the sign. So initial momentum, like we said, is 0. The final momentum is 5.3 multiplied with 10 plus 59v. 59v. So that comes out as, if we conserve the momentum, then P initial is already 0. P final is 53 plus 59v, and that should be equal to the initial momentum, which is 0, if it makes sense.
Um, Final is, yeah, 53 plus 59v equals 0.
Yeah. So from here I get the value of the velocity as negative 53 over 59 meter per second, if it makes sense.
Yeah.
Okay, let me just quickly go ahead and check our answer as well. Just don't want to have anything incorrect over here. 7, 7, 7. Yeah, 53 over 59 is 0. Yeah, that's correct. All right, okay. Makes sense, right? Any questions on this one?
Just when I convert it, I get negative 0.898. And now if I have to do two significant figures, would I do, if it's 898, would I take 0.89 or would I take 0.9 or would I just take 0.898?
So that's a good question. The answer is negative 0.898305, whatever. And you're talking about two significant places, right? Not two decimal places. You're
Two
talking about two
significant fig
significant
no, two
places.
sig figures, yeah.
So two significant places would imply negative 0.89, and rounding this 9. If I round this 9, then this becomes 0, and this eventually becomes a 9 as well. So this will become negative 0.90 up to two significant places.
Mm, okay.
And
We've
fortunately,
always
this
been
is
confused.
also up to two decimal places as well in this case. But ideally, it should be reduced to three significant places.
I know in physics what we do is the amount of significant figures that you use in the calculations is what you have to use in the answer. So
Yeah,
if in
that's
the
that's
calculations the smallest thing you
that's
have is like 59, you do two significant figures.
yeah, that's why I'm saying that if you notice carefully over here, everything is in three.
Mm. Oh yeah, because it's 5.30.
Correct. So ideally, this should be with three significant, which for which we do not have any confusion. It is this. But yeah, that's a good question.
Mm. Thank you.
Two significant places and three significant places. All
So
right.
just
Okay.
gotta blow my nose quickly.
Uh huh. Right. Let's pull up some more questions for us. Okay. All right. Are you good for homework if I give you this time?
Yeah. Now
Okay. All right.
I can take homework because I got easy weekend.
Mm-hmm. The subparticles, the objects breaks apart into two energies. Okay, the 11, question number 11 is a homework.
Hmm.
All right, we will try question number 10 is also homework, or otherwise, question number 9 is a homework. Question number 10 we'll try now. An object at rest is suddenly broken apart into two fragments by an explosion. So this is a classic case of conservation of momentum. Whenever there is a particle which breaks down into, explodes, breaks down into fragments, into
Hmm.
pieces, then always remember that all the internal forces during the collision are cancelled and the net force is zero, and hence the momentum is conserved. Now, one fragment acquires twice the kinetic energy of another. And remember that the object was initially at rest. So, what is the ratio of their masses? All right. So, let
So
me
half
know if
mv
you.
squared
Correct.
equals 2 half mv squared.
Yeah. So initially, this was the mass sitting at rest, and then
Hmm.
it suddenly got exploded into two fragments. Now we do not know what are their masses. So let's say this is m1 and this is m2, and let's say this has a speed of v1 and this has a speed of v2. Obviously it doesn't make any sense that both have in the same direction, but once again, let physics tell us. We'll assume what it is. Initial momentum is 0. I hope you agree with me. And the final momentum
Yep.
is m1 v1 plus m2 v2. Makes sense?
Hmm.
Okay. All right. So can I say that m1 v1 plus m2 v2 is equal to 0?
Yeah.
Because the momentum is conserved. And now, as you were saying, uh, initiate the kinetic energy of one of the fragment, which is this, is twice of the kinetic energy of the other fragment, if it makes sense. Yeah?
Yep.
This 2 and 2 is gone. So can I rearrange it as 1 over 2 times m1 over m2 by dividing both sides with m2? And by dividing both sides with v1 square, it's going to look something like this. Let me know if you agree with me.
Wait, are we going to do a simultaneous equation now? Is this like a separate equation? Or is this continuing on from the m1 v1 plus m2 v2?
Right now, we have not touched this one again. That remains where it is. I'm just simplifying the kinetic energy thing right now.
Okay, yeah, no. Okay.
Does that make sense this much?
Hmm.
Okay, all right. Now, can I say that from this equation, remember that we need to find the ratio of their masses, but we do not know their individual velocity. So we have to get rid of the velocity somehow. So can I use equation number 2, equation number 1? Let me make some space. And can I rewrite it as m1 v1 is equal to minus m2 v2?
Hmm.
And can I take ratio of, can I divide both sides with negative m2, and can I divide both sides with v1 to write this as another form of that equation? Let me know if you agree.
Hmm.
And don't you think the value of v2 over v1 can be substituted over here now?
That would just be m1 over negative m2 squared.
Correct, whole square. So can I write it like this? Half of m1 over m2 is m1 square over m2 square.
Hmm.
One of the m1
Why?
is gone, one of the
Oh, yeah.
m2 is gone. So the ratio of the two masses is 1 is to 2.
Mm. So that. Okay, okay. I see.
All right, I'll just zoom out. You can write this and then we'll move ahead.
Yeah. 2 m1 over m2 equals m1 squared over m2 squared. Then we can cross these two out, cross out, cross out. 1 over 2 equals m1.
This is more algebraic rather than, I mean, the physics concepts. They were testing you on algebra.
Mm-hmm.
Makes sense. Can I move ahead?
Yeah.
Okay, all right. Try question number 12 now. Okay, what is this? The speed of away from the. Alright, okay, let's do away with that. Let's try question number 12 for the moment. Alright. A 0.145 kilogram baseball pitched horizontally at 27 meter per second strikes a bat and pops straight up to a height of 31.5 meters. If the contact time between the bat and the ball is 2.5 meter per second, then what is the average force exerted between the ball and the bat during the contact? Don't you think the formula used over here will be F is equal to d delta P over delta T? We talked about this in the last class, right?
Mm-hmm.
So can I say that the average force is nothing but the change in momentum over the time of contact?
Yeah.
The time of contact is already known to us as 2.5 times 10 raised to minus 3. That is in seconds, so that is in seconds. Now the question is, what is the change in the momentum? And we have to be a bit careful about this because this was, let's say, the baseball and it was going at 27 meter per second. And after striking the bat, we do not know what is its velocity, but we for sure know that after colliding, it rises to a height of 31.5 meters. This is the only thing which we know. So using kinematics, we need to find the unknown velocity v, because it's only that when we know the unknown velocity, we have the momentum. And only when we have the final momentum, we can find the change in the momentum. So this is once again reminding you of the unit 2 kinematics of 1D motion. Which equation of motion do you think it's helpful over here to find unknown velocity v?
Hmm. Um. We have time. Do we use the time?
Time is which time? Time of
Wait, can I see
contact.
the
Yeah, question. Yeah, sure.
the question again? Just wanna. Mm, but we don't have any acceleration. That's the thing.
It's going up. What is the meaning of going up in the air?
That means that there's no there's no distance, like no displacement.
It is bat hits the ball and ball goes up.
Mm-hmm.
Don't you remember
Mm-hmm.
don't you think this is a free fall case?
Oh, it's free fall in it.
So don't you think there's an acceleration due to gravity here?
Yeah.
And
Mm-hmm.
it finally stops. So don't you think I can easily find the value of v? Which equation do you think would be helpful for us?
The second, third one.
Third one. Okay, go ahead. Please give me the value of v.
So that's v squared equals v o squared plus 2as. Um, the v squared is what we're looking for, but we don't know the vi either. Oh no, v squared is rest. It's final. VO squared plus 2 times 9.8 negative 9.8 times 31.5. V squared is 617.4 square root. Oh, I did square root of a negative. Square root. VO is equal to 24.8 meters per second.
Okay, very good. So the change in momentum is P final minus P initial. We know that very well. And that will be nothing but mv final minus mv initial over 2.5 times 10 raised to minus 3. M can be taken as a common factor, so if m is taken out, I'm left with v final minus v initial over 2.5 times 10 raised to minus 3. M is given as 0.145, so it becomes 0.145. Now the question is, how can we, okay, I will write the denominator as it is. Now the question is, how can you subtract these two vectors? Remember, these are vectors, these are not scalars. So you have to subtract a vector which is going right up with a vector which is going towards the right.
Pythagoras.
Exactly. Go ahead, please give me the difference.
So it's square root of 27 squared plus 24.8 squared. 36.6.
What is the final answer?
1 second, let me just write this down. This is 27 squared plus 24.8 squared over 2.5 times 10 to the power of negative 3. Force is equal to, so we got 0.145 times this divided by 2.5 times 10. 2,126.35
Absolutely. So
newtons.
2.13 times 10 raised to 3 Newton approximately is the average force exerted by the bat on this ball in the situation. Does that make sense?
Mm,
Sure. Any questions?
no,
Okay,
it's
all
good.
right. Okay, all right. This is good. So let's move ahead to the next set of questions: collisions and impulse. Um, all right, a couple of questions on impulse. I'm very sure you are okay with this, but still, I think it's a good idea not to leave any question. Um, yeah, all right, okay. So I have a couple of questions over here. All right. Definitely question number 18. We'll try together. Question number 17. How about you do as a homework?
Okay.
Golf ball hit the tee speed, goes contact. That's fine. Right. We'll do question number. Okay, let me see the other page. Acquires the speed by pushing her legs. And what is the change in the speed of the capsule? The rain is falling at the rate of an occurring. So in the pan, the rate drops. I estimate the force at the bottom of the 1 meter square pan due to impacting the rain, which we assume does not rebound. Mass of the fullback is running to the east and is stopped by a head-on stacker by running tackling to the original momentum of the fallback. The fullback impulse. We'll try question number 21 as well. All right, please go ahead. Try question number 18.
Okay.
A tennis ball of mass 0.06 kilograms at speed of 28 strikes a wall at an angle of 45 degree and rebounds with the same speed. What is the impulse, magnitude, as well as direction?
Okay.
Okay, so we're gonna do this together because this is our two-dimensional momentum. Because you can clearly see that an oblique velocity will have a velocity in the x component and in the y component as well. So the situation is it has a velocity over here and some velocity towards Vx and some velocity towards Vy before colliding. And after colliding, can I say that it has velocity over here and velocity over here? If you agree with me, after colliding.
Yeah. Mm-hmm.
Okay,
Because it goes in there and then up there.
correct. This is 28, and if you can help me with this angle, don't you think this angle is also 45 degree because they are alternate angles?
Yeah.
So can I say this is 28 cosine of 45 and this is 28 sine of 45?
45, 28. Do we not use the 28? Yeah, we use the 28. Oh, but 28 cos. Isn't it mg cos and mg sin?
We are not talking about force, we are talking about components of the velocity. So
Oh,
velocity
and
has a
so we use.
component of 28 cos. I mean, it's very simple. The magnitude is 28 and along the angle is the cosine component. So cosine 45 and then sine 45. As simple as that.
Oh, so for this case, instead of using mg cos 45, we use the angle cos the other angle.
No, mg cos 45 had the same. Okay, you are remembering the inclined plane, which is okay. But remember that mg was the force, and we used to make the components of the force when we were talking about dynamics. Right now, it's all about velocities and momentum. So I'm interested in making the component of the velocity.
Oh, wait, no. 28 is the speed.
Yeah,
I read the question.
so rather than mg being the force, we just use v as our velocity. It's all about the magnitude of the vector. So in this case, the magnitude is 28, and I want to resolve the components, so that should be 28 cos and 28 sine, if it makes sense.
It's just the way that you drew the thing. I thought for some reason that the 28 was that small angle inside, and I was like, how is that 28? And
Oh,
that.
no, no, no. 28 is the magnitude, and I'll draw it over here. 28 is the magnitude, and 45 is the angle. Makes sense?
Yeah.
And likewise, can I say that this is also 28 sine 45 and this is also 28 cosine of 45?
Mm-hmm.
Now remember that we need to find impulse. What is impulse, if you can remind me?
Isn't that the change in
Exactly.
mechanical energy?
No. Whoop, 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 whoop,
Oh,
whoop.
change in
Change
momentum,
in the
momentum. Sorry.
momentum. Change in the momentum. So change in the momentum is nothing but, after all, change in the velocity, because mass is a constant and it comes out. So we can say that it is the change in the velocity. Now, notice carefully what is being changed. The initial velocity, because initial velocity is basically multiplied with a negative sign. So if we change the initial velocity and add with the final velocity, don't you think that this component, which is towards the top, will go to the bottom, and the
Hmm.
component towards the right will go to the left because it has changed. A vector is multiplied with a negative sign.
I see how Vx will go the opposite direction, but why would Vy be flipped upside down?
Because it's also a vector, right? It's a part of the vector. Everything which is
Hmm.
multiplied with negative sign will be revolved, will be rotated 180 degrees.
Oh, okay.
Another way to
No,
understand this is, I
right,
think
okay.
you are not quite aware of the I cap and J cap, otherwise I would have explained you that way. But another way to understand this can be uh, M remains as it is. And what is M?
M is 0.060.
M is 0.060. So I'm going to write M here 0.06. V final is, can I say that V final is minus 28 sine 45 degrees x cap? I mean, in the x direction. So I'm just representing that with a x bar. And 28 sine 45 in the y direction. So let's say y cap, just a representation to make sure that in which direction it is. Do you agree with this?
The negative 28, that's because it's flipped, right?
No, I'm talking about only the final velocity, which is this. So since this is towards the left side, I'm
It's
representing that
negative.
with a negative sign. Minus the initial position, and initial vector is 28 sine 45 degree towards positive x and 28 cos 45 towards the positive y, if it makes sense.
Not really. Could
This
you
is
could you
28.
re-explain it, please?
Yeah, yeah. Final velocity makes sense, right?
Yeah, no, I see.
This is the final velocity. Minus sign remains as it is, and the initial
Hmm.
velocity is only this much.
Yeah.
Because
Okay.
28 sine 45 is towards the right, so I've taken it as positive, and 28 cos 45 is towards plus y side, so I've taken it as y only. Does that make sense? Yeah.
Wait, but what's the point of the I cap and X cap?
That's to indicate the directions, because once you open this, distribute this negative sign, don't you think that the situation is going to look like this? In fact, you know what? Actually, let's try to understand this I cap and J cap, because it will be easy for our future classes as well. It's nothing too complicated. I cap is a representation of a vector which is in x direction, plus x direction. Likewise, minus I cap is a representation of a vector which is in minus x direction. J cap, or sometimes it's called J hat as well, it's called in plus y x plus y direction.
Why isn't it then just X and Y cap? Why did they make it I and J?
This is actually the vector notation. Whenever you go in 3D vectors, they represent as I, J, and K. This is the usual representation of the vectors. X and Y are pretty much variables. These represent vectors. So yeah, it's pretty much like that. And this is in minus
Okay.
Y direction. So let's say in future you get a vector which says 12i. So it means that the
There's
vector
12.
has a magnitude of 12 and it's pointing towards the right side. Does that make sense? If you get minus 12j, it means that the magnitude is 12 and it's going towards minus y-axis. Makes it easy, right?
Mm, yeah.
So if I write now in terms of I and j, it will be very easy for us to understand. Can I say that this is I cap, this is j cap, this is I cap, and this is j cap as well? And if I now
Yeah.
open up the or distribute this negative sign, don't you think it's going to look like this? So first half remains as it is. I think I've made a mistake here. This should not be sine. This should be cosine 45.
Yeah.
Minus, if we distribute the negative sign, it's going to look like this. And if we notice carefully, these two are gone.
Sine 45 I cap plus 28. cos 45 j cap minus 28 sin 45 I cap minus. Oh yeah, and then we can cross these two out.
So the beauty of this method is not only you got the magnitude, but the direction as well. Because now if we open everything up, this will become 0.06, and basically these two gets added because they both are with negative, right? So can I say that it's minus twice of 28 sine 45 I cap? Because there are two
Yeah.
of them. Can you multiply everything and give me the magnitude?
Negative 2.38.
So look at that. They were asking the magnitude as well as direction in the question. And if we use I cap and J cap, not only we got the magnitude, but we can now clearly say that it is obviously towards the west direction because it is towards the minus x direction, if that makes sense.
Yeah.
All right. We learned something new, I cap, J cap, not at all complicated, but it really helps us, especially in the question of momentum. This will really help us. I'll zoom
So let
out.
me just write down a little bit about I cap, J cap. This is positive x direction.
Right, here you go. This is the board.
This is, yeah, thank you. Negative x direction. Positive y direction. Negative y direction.
Okay, all right. Let's talk about question 21.
All right. 21. Africa kilogram fallback running at 3 east. So it's this way. 95 kilograms, 3 meters per second. Stopped. 0.85 seconds by a head-on tackler running due west. Original momentum of the fallback. Impulse. Okay. So PI fallback equals 95 times 3. 285 is the A.
Sorry, 285 is part A, which is the initial momentum. So it's mass times velocity. 3 is 15, 1, 9, 28, 285 kilogram meter per
Yeah.
second. Part B.
Kilogram meter per second. Part B.
So when we say
Impulse
impulse, we
mixture.
need the direction as well.
Okay. Impulse equals PF minus PI. Which equals MVF minus VI. But it's not. Can it be MVF VI?
Yeah, okay.
but we don't know anything about the other tackler.
No, you have to find the impulse of the full on the fullback.
Mm. His final velocity after he collides with the dude.
Yeah, so he stops, right? It's written, is stopped.
Oh, it stopped. So it's zero.
So don't you think we can say that it is PF minus PI and PF is zero? This is the answer.
Yeah.
All right, what about part C? Impulse exerted on the tackler, given that we don't know anything about the tackler's velocity. Still, can we find a change in the momentum or the impulse?
Well, we know he's moving east uh for 0.85 seconds and then stops.
No, tackler is going west.
Yeah, tackler's going west for 0.85 seconds before stopping.
No, 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 no. The tackler is going, they collide for 0.85 seconds. The collision time is
Is it?
0.85 seconds.
Oh, okay.
Okay, the concept is very easy. The momentum is
Would that
conserved,
just
right?
be the force to change in momentum over change in time?
Yeah, the momentum is conserved, right?
Yeah.
So can I say that the change in momentum of the tackler is same as the change in momentum of the is equal and opposite to the change in momentum of the pullback because the momentum is conserved. Okay, all right. Another way to
For
understand
both of
this.
them?
No, it's a system. Try to consider it like a system. This is the fullback. This is the tackler. He was going with some velocity. He was coming with some velocity. And after the head-on collision, they both come at rest, correct? So can I say that initial momentum, whichever it is actually equal to the final momentum of the system? Final momentum is zero and initial momentum is whatever it is. Can I say that the initial momentum is a combination of the initial momentum of the fullback plus the initial momentum of the tackler?
Yeah.
So can I say that the momentum of fullback is equal and opposite to the momentum of tackler?
Oh, yeah.
So answer is same except the opposite sign. So it's 285 kilogram meter per second towards the x direction. That's one way to understand this question. Another way is pretty straightforward. Try to think about it like this. These two guys, when collide, and this is fullback and this is tackler, don't you think fullback exerts a force on tackler towards the right side and tackler exerts an equal and opposite force on fullback towards the left side?
Mm-hmm.
So since they're equal and opposite force and the contact time for both of them remains the same, so can I say that F dt and F dt for both of them are same but in opposite directions? And what was F dt? We already read that. Don't you think F dt is change in momentum?
Mm.
Makes sense or no? Yeah? No?
Yeah, 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 sorry.
Okay, all right. So that is the only reason why, because of the equal and opposite forces, they have the same impulse in equal and opposite direction. Since on the tackler, the force is towards east side, that's why it's coming as positive. We're using the math as well. You know, math works out to be positive. On fullback, it is on the west side, so it's coming as negative. Make sense?
Mm-hmm.
All right, so the takeaway here is during collision, the momentum of the impulse of both the parties are equal and opposite. All right, can you work with the last part? What is the average force
Okay,
exerted on the tackler?
so F is equal to change in P over change in T. Um, this is equal to, well, change in T is negative 285.
We are talking about the tackler. So on tackler, change in momentum is towards the right side. So it's positive, not negative.
Tackler, isn't the tackler the one who runs west?
Correct. So the force exerted on him is east.
Is east. Oh, okay. 285 over 0.85 is equal to, F is equal to 335.29 newtons.
All right, that's correct. So I think this is what we had for today. And